Hello once again. So today we'll be doing page 249. We'll be using this textbook. It's N6 Bsc, page 249. What we'll be doing today is steel columns. So we have a question here, a statement which says an H profile plated steel column is 2.7 meters high. The column is effectively held in position at both ends and restrained against rotation at one only. So before we can dwell into questions, when you are doing steel columns, you need to take note of this statement that is here. The column is effectively held in position at both ends and restrained against rotation at one end only. So when you're dealing with steel columns, this is the table that you'll be needing. Make this table your friend, page 327, this table. So this table has the statement there that was stated, and then the effective length that you need to use. Okay, so they said the column is effectively held in position at both ends and restrained against rotation at one end only. So you go to page 327 and look for that statement here. So it's this one, number 2, effectively held in position at both ends, restrained against rotation at one end only. So it means our effective length is going to be 0.85 L. Okay, so that's how you choose. Okay, let's move. Here we are given our steel column with its dimensions. So we have 3 plates here. Plate number 1, plate number 2, plate number 3. Okay, and then plate number 1 and number 3, they are the same. Same measurements, the breadth is 180, the depth is 20 on both of them. Okay, so what is the size of this plate number 2, this one that is inside? We have 180, and this 180, if you can look at it very well, it covers this plate, these 2 plates. So for us to get this plate that is in the middle, we need to subtract the size of this upper plate and the size of this bottom plate. So I'm going to say 180 minus the size of this one, which is 20, minus the size of this one, which is 20. So it's 180 minus 2 of 20. Then we'll be able to get the inner one, which is 140. Okay, so calculate the following. Number 1, the effective length of the column. So how do we calculate the effective length of the column? So we calculate the effective length or height of the column. Okay, so remember we went to that page 327. So that is the table that you will use for you to get the effective height or effective length of the column. Okay, so effective length, it says 0.85 L. Where do we get the 0.85 L from? Page 327. Okay, so in this L, you're going to substitute what you were given there, which is the 2.7 meters high. You substitute the height of the steel column. Okay, so 2.75, you substitute it there. So it's going to be 0.85 times the 2.75 there, and we'll get 2.34 meters or 2,340 millimeters. Okay, then you'll write your reference there. This is reference. You'll write your reference there. Okay, and then after calculating the effective height column on the very same question, you calculate the effective cross-sectional area of the column. Because in number 2, they said we should calculate the minimum second moment of area, and we are going to need this area. Okay, so calculate the effective cross-sectional area of the column. So it is, the formula is B times D. As you can see, these are all rectangles, and rectangle, this is B, this is D. Okay, so we have our breadth, we have our depth there. Okay, so it is breadth times depth. What is the breadth of this plate? It is 180. What is the depth? It is 20. The depth is the height. Depth is the height. So the height here is 20. The height is not 180. The depth is 20, which is the height. So remember that this plate and this plate, they are the same, they're identical. So what you can do is to say 2 into the B, which is 180, multiplied by the depth, which is 20, and then plus this, the area of this plate. The area of this plate is breadth times depth. So what is the breadth? The breadth is let me see, the breadth is 18, and then the depth is 140. Okay, so there it is. We'll get 9,720 millimeters squared. Okay, let us move. So now, number 2, they said we should calculate the second moment of area about the x-axis. So calculating the second moment of area about the x-axis, they want ixx. So ixx is equal to 2 into, remember this 2 into is because we have 2 of the same column, okay? Yeah. So it's 2 into bd cubed divided by 12. I'm not sure if you're able to see this. Here is the formula. It is bd cubed divided by 12 plus al squared. So this a is for area, okay? This a is for area. So it's 2. This is the 2. What is the breadth? Remember, it is for this 2 plates. So the breadth is 180, as you can see there. And then the depth is 20 cubed divided by the depth is 20, and then cube divided by 12 plus 180 times 20, it's the area. 180 times 20 is the area. Get the area, it's b times d. The area, it's b times d. So that is the area. And then where is this 80 coming from? Someone could ask themselves. So we have 180 from here to there, 180. So 180. So we'll say this 180 that we're given from here to there minus, what is the size of this? It's 20, okay? So we need the middle of it. So 20 divided by 2 is 10. It means from here we have 10, and also that side we have 10, this side we have 10, this side. So it's 180 minus 10 minus 10. So 180 minus 10 at the top minus 10 at the bottom, it's going to give us 160. So this L, we are actually looking for the neutral axis. Neutral axis, half of all the shapes, okay? So we have 180 minus 10 minus 10. Or we can say we want the neutral axis. So if we want the neutral axis, we are going to start at the center of this shape. So at the center of this shape, it is 10. Again, we have 20. So the center of this shape is what? It's 10. So it's 10. And then remember, we have the size from here to here, which is 140. Again, we said 180 minus 20 minus 21, the previous one, to get this one again. So we have 140. And we want to start at the center. So we can say we have 10 here plus 140 plus 10. We start at the center of this shape. So at the center, it's 10. And also at the center of this one, it's 10. So it's 10 plus 10 plus 140. We have 160, okay? And then 160 still, 160, it's from here to there. It is not the neutral axis, and we want the neutral axis. So we're going to say 160 divided by 2. We will get 90. We'll get 80, sorry. We'll get 80. So this is where the 80 comes from. Then you square it, okay? Plus, this BD cube divided by 12 is for this inner plate. It is for this inner plate, okay? So the breadth is 180, and then the depth is 140. Remember, the depth is height, d is height, and then you will calculate it there. SI unit for ixx, it's millimeter to the exponent of 4. So there it is. So now let us move. We'll calculate the second moment about the y-axis. Let's calculate the second moment of area about the y-axis. So ixx is equal to 2 into bd cubed divided by 12. This one has no a plus al, as you can see. It is not like the ixx. This is how you calculate iyy. So it's 2 into bd cubed divided by 12 plus bd cubed divided by 12. So the mistake that people can do here is to say this b, I get its breadth, which is b is 180. Yeah, b is 180. The mistake that someone can make is to say the b is 20. So if you interchange incorrectly, you're not going to get the correct iyy. So make sure that you know what breadth is, what depth is. So I'm giving you a hint that d is the depth, it's the height. So once you know that, oh, my height is 20, it means the one that is left, it's going to be the breadth, okay? So the formula for ixx is not bd cubed, it is actually db. Instead of bd, again, ixx, it was bd. So iyy, it is db, not bd. So you interchange. So what is our d? It is 20. This is the 20. This is the depth. Our depth is 20 there. Okay. So IYY you interchange. It is not BD but DB. So it's 20 times the breadth is 180. Also for the other one, it's DB, not BD. As you can see, B, they said the B is 140 and the B is not 140. 140 is the depth. So IYY it's DB. So D multiplied by breadth. Depth multiplied by breadth. IXX is BD. BD. IXX is BD. IYY is DB. Okay. So that's how we do it. Then now let's move. They want us to calculate the radius of gyration about the x axis. So the formula to calculate the radius of gyration about the x axis is r is equal to the square root of ixx divided by the area. All this is inside one square root. The square root is not only for ixx. Both the ixx and area are inside the square root. So it's radius is equal to the square root of ixx divided by area. So ixx will have calculated it, I guess, and then also the area, we calculated it in 1.1. This is the area, okay? So we'll calculate and then get our answer. Also for the yy, you substitute IYY, the same area, okay? That is how we calculate the radius of gyration. And then calculate the slenderness ratio. The formula for us to calculate the slenderness ratio is L divided by R. This L is the one that we got here. It's the effective length, okay? So for us to calculate the slenderness ratio, it is L effective in millimeters, because also the radius is in millimeters, okay? So it has to be millimeter divided by millimeter. So it's the L effective, which we calculated 2340 divided by the radius of gyration. They chose 44,8. Why one? It's 44,8, but we calculated 2 radius of gyration. The question had said it wants the minimum. That's why here they used 44. That's why they used 44,8 here. It's because the question had said they want the minimum. I guess. So it's L effective divided by R. You calculate, you'll get 52,23. So in still column, if you get this kind of still column, you do not round off. We got 52,23, okay? It has no unit. So this 52,23, you go to the back of the book and then you go to page 326. This is page 326, this table, okay? So in this table, we're going to look for 52,23. So this is what you do. We have 0, 10, 20, 30, 40, 50. So we're looking for 52. You go here. Don't make the mistake of using this. No, this is not incorrect. Use this one that says plus 1 plus 2 plus 3. So it's 50 plus 1 plus 2 is 52. It's 132, okay? So it means we have 132. So our answer is 132 there, okay? 132. Here's our answer, 132. But our slenderness ratio did not have it had a comma. So if it has a comma and then numbers after the decimal, it means also the answer needs to have numbers after the comma. Numbers after the comma, okay? So you do not round off. So we got 132 by going to that table. So how do we get this 75 here? You're going to say 23 plus 52. It is going to give you 75. 23 plus 52 will give you 75. And then if you say 23 plus 52 and it gives you a number that is greater than 100, what you do is subtract. Instead of adding, you subtract. You're going to say 23 minus 52 or 52 minus 23. If you say 23 plus 52, it gives you a number greater than 100, okay? So in a still column, if there are numbers after the comma, you do not round off. Your final answer also needs to have numbers after the comma, okay? So it's 52,23. You go to the table, you look for 52, and then how do you determine the number after the comma? You say 52 plus 23, you get 75. Then it's in MPA, okay? The last one, they wanted us to calculate the maximum load. So load is equal to stress. Stress is this one, the one that you just calculated in slenderness ratio. As you can see, it's given in MPa and stress is given in MPa, and then multiplied by the area. The area, we calculated it in 1.1. This is the area, okay? So yeah, thank you.